Okay, let's just jump right into this. In today's explainer, we're going to connect two completely, wildly different worlds. On one hand, you have the absolute deepest, darkest oceans right here on Earth, and on the other, the furthest freezing reaches of our solar system. You know, we usually think of space exploration as looking up, right? But today, we're actually looking down, way, way down. Because to figure out what might be waiting for us millions of miles away in space, we first have to plunge 10 kilometers into the crushing depths of our own planet. And that brings us to this massive, really intriguing mystery. Why exactly is a space agency searching the bottom of the ocean? Right off the coast of Florida, about 20 meters deep, sits the Aquarius Reef Base. It's the world's only underwater lab. NASA is down there operating right now. And they've even deployed an autonomous submarine called Orpheus that dives a staggering 10 kilometers deep. But why? I mean, the US already has NOAA for ocean research, right? So what is NASA doing in the abyss? Have they found signs of alien life down there? Or is something else entirely going on? Well, to actually pull this off, NASA put together Project NEEMO. That stands for NASA Extreme Environment Mission Operations. Every single year, they send 5 to 6 researchers down into this underwater base for weeks at a time. And get this, they don't even call them astronauts, they're aquanauts. And while these folks are working, that autonomous Orpheus sub I mentioned is just plunging 10 kilometers down into the dark. NASA isn't just visiting the deep ocean, they're actively treating it like an alien world. To really grasp how insanely difficult this is, think about what the famous geophysicist Edward Bullard once said. He pointed out that we actually know more about the maps and atmospheres of the Moon and Mars than we do about our own oceans. 2/3 of Earth is covered in water, yet reaching the deep sea floor is so dangerously difficult that we literally have better maps of Mars. The ocean is violently hostile to human life, and NASA is using this completely unmapped territory as the ultimate proving ground. To put that hostility into perspective, think about the number 25. Specifically 25 milliseconds. That's the absolute minimum amount of time it takes for a human brain to actually register the sensation of pain. Now, think back to the tragic Titan submersible implosion. That sub was about 3.5 kilometers deep. When it failed, the immense atmospheric pressure literally vaporized the vessel instantly. It happened so fast, under 25 milliseconds, that the people inside didn't even feel a thing. The pressure is just absolute. And NASA's Orpheus sub? It's diving 3 times deeper than that.
Section 1. The recipe for life.
So how do we actually get living organisms from completely non-living atoms? NASA scientists are operating on a foundational proof of concept here. Life on Earth started in the deep ocean, and it requires 3 very specific steps. First, you need water. That's the medium. Second, energy, the catalyst. And third, chemistry, the interacting elements. Think of it like making a cup of tea. If you just throw dry tea leaves, sugar, and ginger into a pot, absolutely nothing happens, right? They don't magically become tea. You need a medium, the water, and you need energy, the heat from a stove, to make those elements interact. The early Earth needed this exact same setup to spark life. But this is where we have to bust a pretty major myth. You might be wondering, where on Earth does this stove come from in the pitch black ocean? We usually assume that life absolutely requires sunlight, but the truth is it doesn't. Deep down in the ocean's Hadal Zone, this treacherous terrain reaching 11 kilometers down, you'll find hydrothermal vents. Basically, these are underwater volcanoes. They release boiling water, steam, lava, and minerals straight into the pitch black abyss. Life doesn't need sunlight, it just needs energy. And these vents, they provide massive, massive amounts of it. We're talking 400 degrees Celsius. That is how blistering hot the water gets when it shoots out of these deep sea vents. It's literally hot enough to melt solid metal. This incredible geothermal energy comes straight from the Earth's molten core, completely independent of the sun. And it was this exact extreme heat that caused early elements to interact and form complex biomolecules like proteins and RNA. Those eventually became the first unicellular bacteria, which mutated over millions of years into, well, us. NASA is braving the deep ocean to study the literal cradle of life. Which brings us to the ultimate question driving NASA's entire operation. Which space object shares these exact deep-sea conditions? Where else in our solar system can we find this perfect recipe? Well, let's just do some quick elimination. Mercury, way too close to the sun. Venus is highly acidic. We're looking really hard at Mars, but we haven't found liquid water yet. And the planets beyond that are mostly gas giants. They don't even have a solid surface, let alone oceans. So where are we looking? Section 2. Jupiter's icy moon, Europa. The answer actually isn't a planet at all. It's Jupiter's fourth largest moon, Europa. But wait, if Europa is completely covered in solid ice, how could it possibly have a liquid ocean? The secret is this wild phenomenon called tidal flexing. See, Europa is trapped in the immense gravitational pull of Jupiter. As it orbits, Jupiter's gravity literally stretches and squeezes the entire moon, continuously. It's exactly like taking a piece of metal and bending it back and forth until it gets super hot. This constant push and pull generates massive amounts of internal geothermal energy. Because of this heat, the ice underneath the surface melts, creating a global liquid saltwater ocean. And to give you a sense of scale, if you compare Earth's total ocean volume to Europa's, scientists calculate that Europa actually contains double the amount of water that Earth does. Double. It's honestly a staggering thought. A moon that looks like a giant dead snowball from the outside is actually hiding a subsurface ocean that dwarfs everything on our own blue planet. And just like Earth, that alien ocean floor is highly likely covered in those superheated hydrothermal vents we just talked about. But remember our tea analogy? We have the water, we have the energy, but what about the ingredients? Well, studies on Europa's surface composition have proven that it possesses the exact fundamental chemical elements required for life's biochemistry. We're talking carbon, oxygen, hydrogen, sulfur. It is all there. Europa literally has the exact same recipe for life that sparked biology in Earth's deep oceans billions of years ago. Section 3, the Europa Clipper mission. So we have a prime suspect. Now, how do we actually catch it? To truly appreciate this grand cosmic sting operation, we have to talk about the mind-bending scale. Let's compare it to the highly celebrated Chandrayaan-3 mission, which went from Earth to our moon. To get to Europa, the distance is almost 1,600 times farther. Think of it like this. If traveling to our moon is like walking to the building right next door, traveling to Europa is like taking a trip from Mumbai all the way to Delhi. It is a terrifyingly vast distance, completely filled with gravitational hazards, asteroid belts, and intense solar winds. The Europa Clipper is expected to launch in October 2024. But here's the crazy part. It won't just fly in a straight line. The math required for this is just unbelievable. Scientists have to predict exactly where every planet will be years into the future. The spacecraft will launch, fly to Mars to use its gravity for a slingshot speed boost, boomerang back to Earth for another slingshot, and finally shoot off toward Jupiter, arriving 7 long years later in 2031. They are literally navigating the solar system like a giant cosmic game of pinball, bouncing off the gravity of different planets just to build enough momentum. And the finale is even more cinematic. To enter Europa's orbit without crashing, the satellite will have to perform multiple high-speed flybys of Jupiter's other massive Galilean moons, dodging and weaving through their gravitational pulls until it finally settles into place to begin its study. Once it's there, and assuming the data looks good, the next phase sounds like pure science fiction. Sometime in the future, NASA plans to send a nuclear-powered Cryobot. This thing will land on Europa and literally melt its way through anywhere from 2 to 20 kilometers of solid ice. Once it breaches that subsurface ocean, it will deploy a swarm of 48 micro-robots. These autonomous machines, which, by the way, are modeled exactly after what NASA is testing in our deep oceans right now, will swim out into the dark, alien waters to actively hunt for life. Section 4. Humanity's Ultimate Quest. You know, this entire endeavor is so much more than just a science experiment. It's humanity's ultimate quest to find our place in the universe. But there is a massive philosophical hurdle we have to at least acknowledge here. What if alien biology doesn't look like Earth's biology at all? For decades, we've used advanced tools to look for Earth-like conditions. We just assume life must be water-based and rely on DNA. But what if life can evolve in ways we can't even comprehend? By only looking for Earth-style life, we might just be completely barking up the wrong tree. Our model of life could actually be exceedingly rare in the universe. Yet, despite all that uncertainty, there is just a profound beauty in this endeavor. We are uniting the world's best minds for what might realistically be a 1% chance of success. Scientists across the globe are putting aside borders, nationalities, religions, and self-doubt. They're working shoulder to shoulder on a mission that might not even yield a definitive alien microbe. But history proves that when humanity unites for these revolutionary, seemingly impossible quests, the technology and science we develop along the way ends up empowering literally every single domain of our civilization. And that brings us to our final thought. Let curiosity be the ultimate driver of your life. Whether we find alien squids swimming under the ice of Europa, or we just learn a bit more about the terrifying depths of our own oceans, The true victory is the pursuit of knowledge itself. Because think about it, if we do find life hiding in the dark, frozen waters of just one moon, what does that mean for the billions of other unseen oceans scattered across the cosmos? Thank you so much for joining me on this explainer today. Keep questioning everything, and I'll catch you on the next deep dive.